I'd like to take a look at a problem from section 2.2 with you. This is a problem that gets into the topic of one-sided limits, and also just using a graph to understand what the limit of a function is at a particular point. And I found in the past that this can be a topic that sometimes students find it pretty straightforward. Other times students might have a little bit of a trouble distinguishing between some subtleties here. So I think this is a good example to help clear up any questions that you might have about using a graph to determine limits like this. So for part A, this is asking for g of 2. Okay, and the thing to understand or remember what that means is that's just looking for what is the value of the function g when x is equal to 2. Now if we look at the graph here, when x is 2, we see this filled in circle up here at a height of 3. So that means g of 2 is 3. Okay, so we're looking for what is the height of the y-coordinate of the point that we find on the graph when x is equal to 2. The next one says the limit as x approaches 2 from the left of g of x. So that superscript with a negative sign indicates that we're talking about an approach from the left, or numbers that are slightly less than 2. So think about approaching 2 from the left of 2, and what's happening to the graph of g as we make that approach. So as we move toward 2 for x, the height of the graph is approaching 2. It doesn't matter that the function does not actually attain the value 2 there. What's important is where is the function heading as we approach 2 from the left. So the answer to this is 2. Now, in this particular place on the graph, we're going to see that there's a different limit as we approach 2 from the right, because as we move toward a value of 2 for x from the right of 2, okay, from this direction, we see that the height of the graph is approaching 3. In fact, on that portion of the graph, it's actually constant. So the limit as x approaches 2 from the right is 3. Okay. And one thing to always keep in mind with limits is that, again, as I said before, it's not important where the function actually ends up when you're talking about the limit, or whether the function's even defined there. What's important is where is the function heading. Now, part D says the limit as x approaches 2 of g of x. Okay, so this doesn't specify from the left or the right. They're talking about a two-sided limit here. And here's the important thing to be aware of. When we're talking about a two-sided limit here, what we want to do is look back at these one-sided limits. Now these are different. Whenever these are different, that means the two-sided limit does not exist, which I'm just going to abbreviate with DNE. Okay. Let's move on to g of 3. Again, think about what we said up here for part A. If we want g of 3, we're looking for what is the height of the graph when x is 3. Okay? And if we look at the graph here, the height is 2 when x is 3. So the answer to that is 2. Now we've got the limit as x approaches 3 from the left of g of x. Again, think about approaching 3 from the left, and the height of the graph there is 3. So this left-sided limit is 3. Limit as x approaches 3 from the right of g of x. Well, then we're approaching from the right of 3. We're going to be on this portion of the graph, and the height is heading towards 2. Okay. Now they don't ask here for the two-sided limit, but if they had, we'd run into the same situation we did before. The one-sided limits are different, so there is no two-sided limit at 3. Next item here is g of 4. Now there's nothing, we don't see this kind of break in the graph, or what we'll later talk about as a jump discontinuity. We don't see that kind of situation happening at 4, but we can still talk about g of 4. We can still talk about the limit there. G of 4 is going to be the height of the graph when x is 4, and it appears that that height is 3. Now, for part I, the last part of this problem, they're asking for the two-sided limit of g when x approaches 4. So what we want to check is, as we approach 4 from the left and as we approach 4 from the right, is the graph heading towards a common value? And it is. Okay, we see from either direction we're heading up to the kind of peak there, and we already said that that has a height of 3. So in this case we see it, we do have a two-sided limit. It happens to be the same as g of 4, but we'll certainly see other examples where that's not the case. We saw above that g of 2 is 3, but the two-sided limit did not exist there. That's the end of this particular problem. I hope you found it helpful, and have a great day.